organized by SPA and joint event with Quality SG. Our speaker today is Tom Gilb. Welcome, Tom. I'm sorry about that delay and sorry for everyone, but these things, it happens. Let's start and not delay it more than that. Please start, Tom.
Okay. So you can see my first slide, I'm guessing? Okay,
Yes.
so there's a QR there. You can, and for if you want the slide contents, which are quite detailed with quite a lot of free book links and things like that. So I assume you'll want them. The actual slide reference in my Dropbox is down in the right middle. Okay, so welcome. This is about security, but it's about quantifying security, not just talking about it. And the moment we say quantifying, we enter a world I call engineering. In other words, systematic, logical, rigorous thinking about a very serious subject for all of you, I'm sure, security. Long story short, I got a shock about a year ago talking to a professor of cyber security in the Nordic countries, and there's a picture on the right-hand side of his work. Now, you notice the boxes and balls and arrows, but you'll notice there are no numeric relationships, like the degree of a relationship of anything. And so I challenged him. I said, you're a professor of cybersecurity. Surely you, at a very reputable engineering college or university, and you should be quantifying degrees of security and types of security. Do you need any help? And he said, well, I don't have time now. I've got so many academic duties. And that was it. Now, this seems to be the state of the art for at least the academics, and everywhere else I look, it's really very difficult to find anybody taking security seriously in terms of doing engineering work on it. They talk about it, they make nice diagrams. I don't think that's good enough for the complexity and fast-moving and large-scale security problems we have. Here's another example. Here's from a paper sent by IBM and about 10 of the better universities in the US through the White House, to the president. And here's their level 2. Here's security, ensuring the robustness and dependability of the AI network system. That's it. I mean, there is nothing better. It doesn't say how much it ensures the robustness and what robustness is or is not, and the dependability and what it is or is not, and what the AI network system is. So typical management bullshit, I'd call it, except these are academics who you'd think knew what a number was and what a measure was and how to present complex technology. They don't, and the chief of the team from IBM agreed with me on the problem. That there's a little bottom right, there are some slides I presented to them, which they agreed to. So security is not just a noun. We have security or don't have security. It's a variable value. That is, some stakeholders value security and they value different degrees of it, and perfect security would cost infinite money, so we're never going to get that. And zero security sounds very dangerous. So we need something in between, which is as much security as we think we should pay for, and can something cheaper than being bribed by a hacker or something would be nice. I've got a way of thinking about these problems, which I call the Penta framework. And here in the Penta framework, without going into that in detail, it's all defined here, we have a set of things called values, and security is one of many other critical values that we have, such as usability, technical debt, and things like that. And so the problem is, we'll start exploring that we not only have to quantify and engineer security, but we have to simultaneously quantify and engineer all other similar critical values. Now, You got a page with the whole talk on a page. So I could just be there, but each one of those points there will be one or more separate slides, and I'll get into details. But this is the talk on a page, if you like, some principles of security engineering. Here is the here's a list of various values: interoperability, reuse capability, scalability, tailorability, usage, tenacity, etc. These are all different values. All are variables. All can be quantified. And here's our little friend, security. Okay. By the way, over here, the colored ones, these are the stakeholders that are explicitly named as stakeholders for this thing called security. They have some stake in security, some interest in it, and we better figure out what they need and what they want. Here on the left-hand side, we have in my planning language, Planguage, in an app called Valplan, we have an attempt to define security as more than blah, 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 enterprise and government levels of security. We define a scale of measure first. Okay, if you want to say how fast the car goes, you decide whether you want to do miles per hour or light years or something like that. Then you put a number on it, 300 miles per hour. Wow, that's fast. If I just said extremely fast, you might not have guessed that I was talking about 300 miles per hour. But when I got the miles per hour in the scale, and I then say 300 is how fast my Tesla will go, well, not quite, but almost, then we have a much clearer idea of the speed of the car. Okay. So we not only define a scale of measure, but we define points on the scale, like where are we now? And where do we want to be? Where do we wish to be in the future? And so our problem is defined as moving from 10 to 1 for security, and similar moves for all of these others in the same project. That's pretty tricky, and you can't do this with nice sounding management bullshit words. You have to define things better so we know where we're going and when we're going to get there and things like that. Okay, so this is symbolic for all of the other things we have to worry about. We can't just let the security people loose with our entire budget because they're so damned important. Other things are important for other stakeholders too, and they're simultaneously important. It's not like we can deliver all the security and turn around and say, do we have any money left on our budget? What do we do for these other people? Okay. So point number 2, you have to know how much values the other people want. And if they want and have the power to give you budget for, pay for products and services, they want something which is very, very costly, and you have a limited budget or a limited time to deadline, then in fact, you have to know how much of the budget the other guys eat up, and then say, do we have any money budget left for security? And maybe the answer is no, actually. We've eaten up the whole budget and more, and we haven't even started architecting the security and figuring out what that costs. This is a little problem. So maybe we have to back up and either get a bigger budget is one thing, tell the bad news, we have no security today, man, or reduce the perhaps excessive levels of the other values to a level where they're not costing so much and there's a little bit of money left for security. Now, this is what engineers call trade studies or trade-offs, where you're trading off between ideal levels of security and ideal levels of usability and ideal levels of availability of the system and so on. And you've got quite a juggling act. You're actually juggling about 15 critical values simultaneously. Try juggling 15 balls at once. Tennis balls, okay, ping pong balls, who cares? table tennis balls. It's tricky, but you need engineering and you need quantification to do such things. Here's a tool I have, which you can read more about in the references. Bruce, welcome. Where here are a set of values, and here is a set of architectures or strategies, and here in the middle are some ratings about how good is strategy number one for this value, and then for this value, and then, oops, negative side effect for this value, and not as much as we thought, trivial. Here, we don't even know how good it is, whether it's good or bad or destructive, same here. But this table, an impact estimation table, is a tool I've developed for architects, primarily designers, strategy planners, so we can keep track of our best estimate with our best factual evidence of how good is any strategy for example, any value, including security and the other values. Okay. Point 3, a systems architect. Notice I didn't say IT architect. I really think even in IT, you have to think the total system, the people, the machinery, the database, and oh yes, the software. We have too many narrow-minded methods focused on coding, and that's one of our big problems in IT and one of the reasons for high level of failures. Anyway, we need architects to figure out how to juggle these 15 balls simultaneously and do it within the budget and within the deadline. It's possible, but you need to quantify your values. You need to quantify how good your architecture is or how bad it is. And you need to adjust as you do evolutionary value delivery. Some people call them sprints. Here's some idea of the things you have to do here. For example, you need a security designer that will prove that their architecture actually works in the actual incremental delivery, not in their minds, not in their hopes, but one increment at a time. Are you getting the security value at the cost you were thinking of spending for each of maybe 50 monthly increments for a 50-month project or something like that? Point number 4, as I've hinted, I know that BCS isn't quite there yet. They're not called the British Engineering Computer Society yet, but the complexity and size of the projects we are really doing, think National Health Service, for example, is huge and complex. And there is a point in any discipline where you move from being a craftsperson, think coder, to an engineer. Now, we said the word software engineering since about 68 when NATO Science Council invented the term, but we've been interpreting it as a coder is a software engineer. Now, that's ridiculous. They are no sort of engineer. They're a soft crafter. Engineering means thinking, like I'm pointing out here in this talk, with numbers, with multiple dimensions, multiple values, multiple costs, multiple architectures, okay? So I'm claiming if we're gonna get things right in security, the chief technical officer, for example, has to sit down and say, I think I agree with Tom. I actually have an engineering degree, so I have some idea of what he's talking about. We have to train engineering people to deal with security engineering and all other forms of systems engineering. That's why things aren't working yet. That's how things are going to work in the future. So here are some principles of a security architecture, but it all, and you can read them at your leisure, but it all amounts to you have to quantify the security and everything else, all the different strategies for security and everything else. Look at the side effects, look at the multiple costs, the short term, the long term, the human costs, the money costs. And you have to understand the architecture of the system. And it's got little or nothing to do with coding. Okay. Here are some ideas of how to organize a security architecture process, the kind of people you want, a value analyst to quantify the different values like security, implementation responsible, somebody to say, I think we'll go from 90% security to 95% security at the next iteration. And then, oh dear, we only got 1% more security, not 5% security. What are we going to do? We're obviously on the wrong track. Okay, let's call that the specification owner, the requirements owner. There's more, but the point is we're going to have new types of positions for which people are going to have to be trained and get experience. And they center around the idea that our values are variable, quantifiable things, not just we need more security. Let's grow up. And if we're going to master these things in serious systems, we have to train people like this at universities. If universities will not do it, and they're very laggard here, I'm afraid, then we train them in-house. Okay, but we got to do the job of getting the engineers and engineering staff in place. Everybody agrees that our targets or requirements should be clear, but my opinion is nobody does a good job of it. They all have bullshit statements. They do not systematically quantify all the qualities, including security. And so we maybe need to agree on the meaning of having a clear target. I'll give you my opinion. It means we quantify with a defined scale of measure and points on the scale, and maybe different parameters on the scale. We define much more clearly than we do today. Let's say 100 times more clearly than the bullshit user story stuff we are using today. Point 5. We need to be able to estimate how good we think our strategies and architecture will be. So here's this impact estimation table talked about earlier. This is a real one used at the US Department of Defense. And here in one day, they quantified their critical requirements. The second day, they determined their major architectures or strategies. I think they could do it so fast because they've been thinking about it for years, but they didn't have a systematic way of thinking about it. And then on the third day of my work with them, they tried to estimate, the major effects and side effects and costs of these various strategies, and come to some conclusion like, looks like we got plenty of good ideas. Let's maybe start implementing. And in fact, on the fourth day, we start doing agile. We ask simple questions like, what can we do next week to deliver something? We actually focused on this big fat number here and found things we could do immediately to actually move the system forward. It could be moving forward towards more security, or we could choose to move forward towards something else like usability or something like that. So this is symbolic for a means of estimating and measuring. You get feedback, you have an estimate, and then you have real numbers at each sprint. And you use that to manage the whole, that is the whole of reaching all the goals, value goals within the resource constraints, using the technologies we think are hot. Okay. Number 6. I know a secret that most of you don't know. I even found professors of things like estimation who don't know this secret. It was first published in IBM System Journal in 1980, so that could explain it. Like if it's before you're born and in paper, maybe you didn't read it, but I'm trying to keep the idea alive. Long story short, Harlan Mills led a team at IBM Federal Systems Division doing space and military software projects, state-of-the-art, biggest ones of its time, where they had fixed price, fixed deadline agreements with fixed state-of-the-art qualities. And they claimed that they managed to, for years on end, always deliver on time, under budget, the achievement of the objectives, the qualities like availability and things like that. Now, even today, Bent Fluthberg wrote a book called How to Deliver Big Things, where his 16,000 project database, much of which is IT, but not all of which, says that only 0.5% of all of his 16,000 projects deliver on time, under budget, the benefits prescribed. And I have reason to believe that that's exactly the situation in IT. You can Google failed IT projects for starters. Okay. Now, back in 1980, for years on end, IBM publicly claimed and described in detail, the references are in the slide here, how they did it. And the interesting thing is, they did it using Agile, not Scrum Agile. It has no such knowledge, but an Agile with measurement and numbers and feedback and adjustment of the architecture at each sprint. So let's call that really advanced Agile that works very well. And most all of the people who teach any form of Agile have completely ignored this best practice. Maybe it's time we picked it up and started succeeding better than 0.5% of the time. Okay, here's some more detail on how they do it. Long story short, when they deliver a sprint and the costs are too high or the quality, the security is too low, they bring in Robert Quinnen, the architect, and say, Bob, fix it. Find a new and better design right now, and we'll try it out possibly on the next step and see if it delivers better security at lower cost. And by doing that 50 times in a row, by the time they've reached the end of their budget and the end of their deadline, they have adjusted the quality of the architecture and design so that it delivers ambitious levels required by very ambitious institutions like NASA and Department of Defense. This is well worth a study, and all professors of software engineering should teach it, in my opinion. Number 7, okay. A security design is not necessarily just something in the software, like ways of detecting hackers and things like that. A security design can be absolutely anything, like motivation, contracting, policies, things like that. And that's why we have to go to systems engineering. We cannot solve the security problem within code. Okay, so long story short, we need systems architects that will think of whatever is the most effective or cost-effective security, even though it's not a software idea in itself. That's the idea. And we're not currently doing anything resembling that. Point number 8. When we're here's a simple example of quantifying security with a scale of measure. And but there are 2 ideas I want to bring out, that when we quantify our future requirement, we can quantify 2 different things. The tolerable level is the worst acceptable case, the survival level. Below tolerable is intolerable. Below tolerable is failure. We are formally defining failure in advance for the architect, for the testers. Okay. And then the wish level is in our dreams. We'd like to get to this level, and let's call it the success level. Let's call it the definition of success. If it says 98%, then nobody's asking for 99, and there's no reason to over-engineer or gold plate the system to give more than is considered necessary for purpose. So that's my main point there, number 8. Here, by the way, from my competitive engineering book, free digital copy, is there, is the ideas of security quantified. This is back in 2005. And in fact, I published things like this as early as 1976 in my software metrics book. So it's not like there's anything new invented here. Here's our friend security, together with a whole lot of other stuff that can be quantified and is quantified in advance, a template. You don't have to invent it. Okay. Here from the 1976 book, the same stuff, the ideas of quantification of security ideas. So the ideas have been around, and we haven't been ready for them. But maybe you're ready now. Maybe security is worrying you now or overwhelming you. Okay. So time to pick up simple ideas of security and start becoming a security engineer or a systems engineer. Now, I think I made this point before, so I'll be a bit briefer here, but security engineers need to realize that they're not the only game in town. However critical and important it is, there's a heck of a lot of other stuff that determines whether you have a successful or failed system. Here's a simple map of them from the free competitive engineering book. And so, so the question is, are we going to have a systems engineer who is superordinate to a security engineer, right? I think the security engineer has to play ball or cooperate with other engineers, such as a user experience engineer, or I like to call it stakeholder experience engineer, but I won't go there just now. Because there are other very important, very critical things that determine whether this system is a failure or success. Okay, so we need to think of the hierarchy. Systems engineer has a specialist under it called security engineer or security architect. Doesn't much matter what we call it for the moment. Point number 10, this you may have noticed how fast things like security change, and new threats all the time. The hackers are always one step ahead of everybody else, and everything we have to deal with is huge and complex, and we can only actually deal with a prioritized set of it. So the fact is, this is not a one-time job at the beginning of a project. This is a systems life cycle job. Somebody needs to be in charge of security for the life cycle of the system, and monitoring new types of threats and new types of architecture, maybe more cost-effective architecture for dealing with things, and bring it in as part of the technical debt update of the system. I'm gonna, well, when should I stop? This is an interesting question given when we started, but let me try and be brief, because I think most of you were thinking we'd be done with the talk in about 10 minutes. Okay, and we lost about 20 to begin with. Now, here's an interesting guy who held a BCS lecture, and you got the links there, Ben Hansen of Microsoft. And the thing I noticed about Ben was this, that here are some of his diagrams, my clips from, you can see he's on the BCS stage there. And notice there are no numbers. There are lots of relationships. All the arrows are really saying there's a relationship, maybe even cause and effect. Okay. And here's more. No numbers, nowhere, no attempt. Okay. But there are lots of players there. There are lots of stakeholders. There are lots of security strategies. Okay? But this is the great Microsoft, and this is the best they can do. I'm laughing. I mean, if I wanted to hide how bad my methods were, I'd do it exactly like this. I wouldn't give any information about the cost of anything or the security effect of anything or the side effects on usability of anything. I just give you boxes and balls, and I know that a lot of people are going to buy that because it comes from a big player called Microsoft. Boy, how foolish we are. Okay, so what did I do? I'll show you in a moment. I think we'll skip this just for fun. I then took everything of the clips I have there, and I put it into my planning language, Planguage, in my app called ValPlan. And here, for example, are the stakeholders that he mentioned, that Microsoft mentioned. And here are some of the technical solutions, the Microsoft guidance, etc., for privilege, and rationale for Microsoft recommendations. Here are some of the functions they had. I started organizing what he said into stakeholders, functions, solutions, and other things like values and resources, like security value. Now, of course, he didn't have anything except bullshit values. Like we're going to get better security if you just pay Microsoft here. But they didn't say how much security, of what type, or when, for what cost. I mean, as far as they're concerned, they'll charge you forever, like a good outside supplier. Read the book, The Big Con, by a professor at University College London. Find out about these guys. They'll charge you forever for giving you nothing. About time we stopped it. And so here's just more. I'm just showing from the automated mapping. Here are all the security stakeholders from the Microsoft. Here are the yellow lights are all the strategies they mentioned. Okay, and then here are vulnerability to attack. The arrows represent various types of security values that were somehow mentioned or alluded to, but not quantified by them. But of course, I try to quantify them. What is the scale of measure? What is the meaning of coding vulnerability? How do you measure coding vulnerability? How do you measure design vulnerability, right? And anybody can have a go at that. I believe we can quantify absolutely any value, no exceptions, any quality, no exceptions. And in the talk I'm going to hold for the software quality conference in later in June that Margaret has put in the chat, I'm going to hold a talk on quantifying artificial intelligence values, if you're interested in that. That includes safety and security, by the way. And nobody seems to be able to do that. But even the IEEE, I have a quote, says, we ought to do it. We ought to quantify it. They just haven't had time to do it yet. They're so busy with something more important. Can't imagine what that is. Okay. By the way, look at all those stakeholders mentioned by Microsoft. That's something we need to engineer. I mean, in the old days, we had a user and a customer and a use case, and we're all done. Okay, life is simple. But the life mapped here by Microsoft says there's a heck of a lot of stakeholders, and this is only the list from what Microsoft mentioned or had on their diagrams in the talk. I've got another free book for you called Stakeholder Engineering. Where I believe that stakeholder analysis is no longer about customers and users, that's kid stuff for small projects, trivial projects that you should not get paid a lot for doing. Now, you want the highest pay, the highest honors, you need to master a system that has 100 stakeholders, okay, all of which want a little bit of security, by the way, you know. Upgrade yourself to a real engineer. Now the people who have the best chance of this already have an engineering degree and they know what it is. People who've grown up like me as a coder in the 60s have to teach themselves engineering. That is a possibility too. I'm giving you the free books for it. Maybe you can get ahead of the degreed engineers, sneak past them. Okay. So here are some of the security values that I found in Microsoft. So again, they're mentioned, but they're not quantified. Okay. Here is an attempt to take the vulnerability thing and make a scale of measure on it with different parameters and later quantify it. So this is symbolic for how we quantify all those, this particular one, vulnerability scale. But here are the different kinds, many different kinds of vulnerability. Kind of tricky. And here are some of the other alluded to or mentioned security qualities, not just one dimension, right? You know, I said there are many dimensions of qualities like usability and availability in addition to security, but there are many subdimensions of security. And you should at least have a good checklist of what they are. I'm giving you one right here, right now, courtesy of Microsoft, having mentioned them in their talk, but they didn't quantify anything, nor did they say that the quantification is hidden or will be revealed if you pay us enough money. Okay, just for fun, I took the Microsoft stuff and made a simple little impact estimation table of 3 of the security quantifications, 1 idea of cost, 3 of their different bright ideas, and then filled in some admittedly fairly random guesses, but showing that we can organize the Microsoft knowledge in an engineering fashion. I did send all of this over to Mr. Hansen, and who knows, maybe my email disappeared. I haven't heard back from them. They don't seem to have any interest in, and if somebody knows Mr. Hansen from BCS, he could ask, did you get Gilb's attempt to systematize what you lectured at BCS yet? And if he says no, we'll make every effort to get it over to him. You can send this, for example. Okay. Here is a little bit more detail on the attack chain destruction scale of measure and things like that. Okay, so I'd be happy to share even more of this than I have in the slides with anybody who said, I want to seriously take a deeper look at this and maybe do it for Microsoft or for my organization. Okay, but here we are analyzing like a good engineer. Here's the engineering design symbolically, the 3, but there are really 20 of these at least. And here's the security requirements. Again, there are about 12, but here are 3 of them. And here is the future technical debt. Very interesting idea of a development resource. And but there are about 5 or 10 of these when you build full scale. I'm just trying to squeeze it into a slide here. Okay. Here, by the way, is a little automated diagram which says that for each of these values, stakeholder values, here's the connection to the appropriate the design, the security design that impacts it. And here This is relating to one or more stakeholders that like this value. So notice how we can see relationships automatically, as it turns out. This is digital planning. Yeah, to hell with yellow stickies, I say. And we got computers, maybe we should use them for planning. And diagrams like this help us say, well, wait a minute, why do we have no stakeholder for that value? And logically, you can't have a value because these are stakeholder values. You can't have a value that has no stakeholders. So either we're failing to connect it and then have a dialogue, how much security do you want? Or we're failing to identify a stakeholder that cares about this. So there's just something wrong with it, etc. And same token here, if you have a value which has no connection to any design, that might mean we don't have any design for that value. So these are ways of having an intelligent conversation about security. A little bit more detail there. And I want to wind down here. I believe that we have a problem. It's widely recognized. There aren't enough experts trained in security, nowhere. So there's a big problem there. So to one institution here local to me that I've worked with before, the Norwegian Veritas, I suggested that they use these ways of thinking for collecting the knowledge and then disseminating it to their consultants and their customers. I'm disappointed to say that they basically said, thank you, we don't need that. Maybe they're really saying, thank you, we haven't got enough people to even evaluate your idea. But if anybody here is interested, like a university, in a method of collecting knowledge about cybersecurity in terms of numbers, like the degree to which certain strategies contribute to certain values, I think that's what universities ought to do and ought to research. And the research ought to go into a database of this. And my idea of how to do it is for free, right here. Have fun. So goodness me, we're getting towards the end in reasonable time. Here's the summary. If we are going to have any chance of beating the hackers a little bit for a while, we have to consciously make the move to engineering. And I mean real engineering, not coding. Okay, anything less, we lose, they win. Wake up. Look at what's happening. Look at the history of engineering from Egyptian times, right? Maybe ancient aliens did give us these ideas. Maybe they didn't. I'm still waiting to talk to an ancient alien. But, it is like no secret that complex, large-scale systems need real engineering. And I think it's about time the British Computer Society took a position on this. I don't think they have. Correct me if I'm wrong. I've been doing my best to plug the idea, thanks to some of you sponsoring this lecture at British Computer Society. But at some point, this has to take hold. Of course, we have to do this or we're losers. And of course, the British Computer Society has to sponsor more engineering training if the universities don't do it. Who's going to be first? I think universities should be first. Failing that, the corporations just have to do it, and failing that, the societies have to do it. And why not British Computer Society? Okay, nice to think they would do something more than just have some courses and lectures, but nothing else. So what was I talking about? Being numeric, to have an instrument for creating order. Thank you, Carl. And that's it. I'm done. 50 minutes of lecture, not too bad. And those are the there's a lot of references in the back. Or I hope I'm not lying. Oh, I might have taken them out. Okay. Okay. Very last slide. Okay, I'm going to stop screen sharing. However, I stop share. There it is.
All right.
And by the way, you are looking at the Oslo Fjord. And this is where I write my books and hold my lectures during the summer months. And if you ever pass by in a sailboat, I got a place for you to park and come up and have a beer with me.